Hello students, welcome to my class. Today's topic is combinational logic circuits. The definition of a combinational logic circuit is that it is a combination of logic gates. The gates may be AND, OR, NOT, NAND, NOR, NOT, XOR, XNOR. A combination of any of these logic gates will be called as a combinational logic circuit. The property of a combinational circuit is that the output depends on the present state of combinations of inputs. The outputs depends on the present state of the combination of inputs. The types of logic circuits are: there's a group of circuits called as the adders, another group called subtractors, the multiplexer, the reverse of the multiplexer is the demultiplexer. Then there is another group of circuit called as the encoder. The reverse of encoder is decoder. The comparators, which will compare two numbers. And then there are some special combinational circuits called as parity circuits. The first group of circuit is the adders, which are further into two basic adders, the half adder and the full adder. Similarly, the subtractors also, there are two types, the half subtractor and the full subtractor. In this chapter, we have to study each of these circuits one by one. So let us today start with the first basic circuit, which is the half adder. So let us see the half adder. Half adder is a circuit, a logic circuit, which adds two bits A and B. So if this is the half adder block diagram, it has two inputs A and B, and when two bits are added, the outputs generated are the sum and the carry. So this is the first step of any combinational logic circuit, and that is that you draw the block diagram. And the function that the half adder is performing is A plus B. So the function of a half adder is nothing but it is used to add two bits. And let us see how these two bits are added. So when A plus B is performed, the four combinations can be 0 plus 0. The result is a 0 with no carry. If it is 0 plus 1, the result is 1. Again, there is no carry. If A is 1 and B is 0, in this case, again, the sum is 1 with a 0 carry. And the last combination, when A is 0 and A is 1 and B is 1, the result is the sum is 1, but there's a carry of sum is 0 and carry is 1. This bit is called as the sum bit. This is called as the carry bit. So these are the four conditions of the half adder. The second step to understand any combinational logic circuit is to draw its truth table. So if you draw the truth table of a half adder, it will be a table that will have two two inputs A and B, as can be seen here, A and B, and the two outputs are the sum and the carry. So these are the outputs and these are the inputs. Whenever there are two inputs A, B, the four possible combinations are 0, 0, 0, 1, A1, B0, A1, B1. Other than this, there is no other possible combination. To list the truth table, for each of the input combinations, the output has to be listed. We have already seen that when A is 0, B is 0, the sum is 0, there is no carry. So we can list this as sum 0, carry 0. When A is 0, B is 1, the sum was 1, carry was 0. A1, B0, sum 1, carry 0. Last combination A1, B1, sum 0, carry 1. So we have a sum 0 and the carry 1. Having filled the truth table, the third step is to write the output function from the truth table. There are two outputs, the sum and the carry. So we have to find what is the sum function, what is the carry function. If you take a careful look at this truth table, you see that the sum function 0, 1, 1, 0, this is nothing but an XOR function between A and B. This is XOR of A and B. So we may write sum is A XOR B. So this is the sum function. Similarly, if you take a look at the carry function 0, 0, 0, 1 for these combinations, this is nothing but an AND function. So this is A dot B AND function. So the carry can be written as A dot B. So these are the two output functions derived from the truth table. The last step in understanding or completing the combinational circuit is to draw its logic circuit. Logic circuit consisting of all the various types of combinations of gates. So we see that the half adder has two inputs A, B. The sum output is generated by using an XOR between the A and B. So this generates the A XOR B function, which is the sum output. This is an XOR gate. And similarly, the carry function is nothing but an AND function between A and B. So this is an AND gate, and this generates the output A dot B, which is the carry out function. So this becomes the truth table, the logic circuit. If we draw a dotted diagram, block diagram, we now know that the half adder consists of, is a combination of two gates. What are those two gates? The gates are, the first is the XOR gate and the AND gate. Both these gates are the two input gates. So we say that the half adder is a combination of two gates, XOR and AND, and this is the logic circuit, one XOR, one AND, which builds the half adder circuit. The next circuit we will go on to see will be the full adder.